tonight we're working through our Unit 6 test review, which is all about angle measures and is a big introduction into trigonometry. Number 1 says, sketch the following angles including rotation notation, love saying that over and over again, and write down the quadrants in which the terminal sides lie when graphed in standard position. So part A says 467 degrees. Now, 360 degrees would be one full revolution. So if we want to know where 467 is, what we may consider doing is subtracting 360 degrees and coming up with a coterminal angle where we're a little bit more familiar about where that terminal side is going to be. So just a little note here, 467 minus 360 is going to be on 107. Okay, so that means that the terminal side of 467 should be in the same place as the terminal side of 107 degrees, which will be right past the 90-degree mark. It's going to be in quadrant 2. But here's how I'm going to follow it. So I'm going to start with my rotation notation. It's going to go around 90 degrees, 180 degrees, 270, 360. I'm going to go 90 more, but I need to go to 107, so that's going to be a little bit past that. So that's going to be somewhere in this general vicinity. So there's my terminal side. Here's my initial side. You can see the rotation notation goes all the way around once and then a little bit more. So that's going to be our sketch, and this is going to be in quadrant 2. So as far as the quadrants are concerned, they go in order of how the terminal side pans out. So if you're ever wondering, like in Algebra 1, Algebra 2, why is it that the numbers of these quadrants are 1, 2, 3, and 4? Didn't really make sense back in Algebra 1, but hopefully now that you see why they're numbered in that order, it makes a little bit more sense. You're just following the terminal side of this angle measure if it's in standard position. So you just pass through them in that order, 1, 2, 3, 4. Okay, 4 pi over 3. Now, 4 pi over 3, so I might want to label a couple of these just to kind of make you understand here. So 90 degrees is equivalent to pi over 2. Okay, now if we're going to do that in terms of pi over 3s, that's going to be a little tricky. So, I can't just, I guess I could multiply this by 1.5. Yeah, let's go ahead and do that. So that'd be equivalent to, 2 times 1.5 is 3. So that'd be like 1.5 pi over 3. It's a pretty unconventional way of writing it, but I think it'll help you kind of to see where this 4 pi over 3 is really supposed to be. Right? So it's definitely going to be more than this, right? Because this is like only 1.5 pi over 3s, and we're trying to get to 4. Now, 180 is regular old pi, right? And pi is going to equal 3 pi over 3, so we're not quite there yet. And if we go down to 270 degrees, if this is 1 pi over 2, 2 pi over 2, this is going to be 3 pi over 2. Okay, 3 pi over 2. If we convert that to pi over 3s, we'd multiply by 1.5. 3 times 1.5 is going to be 4.5, so this would be 4.5 pi over 3. And we don't need to go any further because what we're trying to sketch here is 4 pi over 3. Okay, so that'd be a little bit less than 4.5. So 4 pi over 3 is going to be down here in our third quadrant. Okay, my rotation is going to start at the initial side, and we're just going to go to about here. I forgot to draw the little arrow on the last one, my bad. There we go. Now it looks a lot better. Okay, another way of figuring out where this thing goes is you could just replace the pi with 180. And if you do 4 times 180 divided by 3, you're going to get 240, which should be less than 270 degrees. So if it's easier for you to just kind of convert everything to degrees, you are welcome to do that as well. Just make sure you do the conversion correctly. The quadrant here is going to be quadrant 3. Okay, part C, got negative 175 degrees. So if we're doing negative angle measures, all that means is that our rotation is going to be clockwise rather than counterclockwise. We're still going to start at our initial side, 0 degrees here, but we're going to go this way. And so if I go all the way to here, this is going to be negative 90 degrees. It's negative 90 right there. If we go all the way here, this is going to be negative 180. And so negative 175 will not, we won't make it all the way to 180. We'll have to stop short 5 degrees. So it's going to be very close. It's going to be something like this. And so the rotation should go around clockwise and hit that terminal side right about here. Okay, so there we go. Those are some sketches of these angle measures in standard position. This last one was also in quadrant 3. Okay, the numbering goes 1, 2, 3, 4. All right, let's move on to the next section. 2a says express 3 pi over 5 radians in degrees. So what we need to do here is we need to replace that pi with 180 and divide by 5. Converting from radians to degrees is a little bit easier because all you have to do is just replace the pi with 180. But you can only do that if you have a pi. Okay, we're going to see in 2c that you won't always have a pi. You gotta, and I'll show you how to set that up when we get there. So 3 times 180 divided by 5. I'm just typing this in the calculator. It's going to be 108. So it's going to be 108 degrees. And this particular one, we do not need to round because it's already a whole number. So yeah, 108 degrees for this one. 2b says express this in radians. Okay, so going backwards is a little bit trickier. And so what we're going to do is we are going to set up a proportion and solve it that way. And that's how we're going to have to do 2c as well. You could do that with 2a. You could set up a proportion for that one. But I just think it's so much easier to just replace the pi with 180 and then just calculate it. All right, so the setup here is we're going to have pi radians is to 180 degrees as x radians, which is what we're trying to find, is to 48 degrees. So just make sure your degrees are lined up, your radians are lined up, and you really can't go wrong here. So once you set up the proportion, we are going to use the cross products property and multiply pi times 48 and then x times 180 and set those two products equal to each other. So we got 48 pi equals 180 times x. Now I'm going to divide both sides by 180, and so I'll get my answer here. 48 pi over 180. Now that is the correct answer here, although you can see pretty clearly that it is not simplified. So what I would do is just throw that in your calculator and try to reduce that fraction. You could do it like, just keep dividing until you run out of common factors, but the calculator will reduce the fractions for you, so you might as well take advantage of that. So this reduces to 4 pi over 15. It does ask for you to reduce it anyway, so good thing we did that. And I suppose I should say radians on there. Make sure to include. Now usually if your number has a pi, it's almost implied that it's in radians, but just to be on the safe side, let's go ahead and label the units just like we labeled this as degrees over here. 2c, 1 radian in degrees. Okay, so here we can't just plug in 180 into pi because I don't have a pi. So I am going to have to set up a proportion kind of like this one. Okay, the relationship of pi to 180 is going to still, that's going to remain intact. But here I've got 1 radian, making sure my radians are lined up, over x degrees. Okay, I'm still going to cross multiply and divide, although this one, it says round to the nearest degree. I have a feeling we're going to have to round this one. So we've got x times pi, so pi x, that was a little bit too much there. Pi x equals 1 times 180, which is just 180. And so x will be 180 divided by pi. Now that is going to be irrational because pi is an irrational number, but we can type it into the calculator and get an estimated value. So 180 divided by pi, got my pi button on here, is about, it says round to the nearest degree, so that's going to be about 57 degrees. Okay, now I'm gonna actually just kind of pause on this problem because I see this mistake over and over again, and there is a problem like this on your test that has to do with like 1 or 2 radians. Just because you don't see a pi, don't assume there's a pi implied. 1 radian is not the same as pi radians, right? 1 radian is about 57 degrees. That's about, you know, right around here in that first quadrant. Pi radians is 3.14 radians. So this is like 1 radian. Pi is 3 of those and a little bit more, and ends up in the same place as 180 degrees. So just be very careful here. This is 1 radian. This is pi radians. These are not the same thing. Although I see this mistake over and over again because you just kind of get complacent and assume there's a pi in there, and that the pi is not actually part of it. You know, I think a lot of students just consider pi to be part of the unit rather than part of the number. But pi is a number. It is not a unit of measure. Okay, so I wanted to pause here and make this distinction because I guarantee you I'm going to have some students that just read too fast and just don't understand that these are different angle measures. So make sure you don't make that mistake. 2D says express 360 degrees in radians. Now this is going to be one of our common conversions, so you should probably already know what that's going to be. But if you don't have that memorized, then we can set up a proportion just like we did for 2B. Again, you really don't have to do this if you know what 2 pi, well, spoiler alert, it's 2 pi. But if you know that 360 degrees is 2 pi, you can just go straight to that answer. Now, 3 pi over 5, that's not one that I would expect you to just know off the top of your head. Pi and 2 pi, those are kind of two of the most commonly used angle measures, so you should start familiarizing yourself with that. But anyway, let's say you just forgot it. You can still compute what that's going to be. Pi times, not 48, 360 equals 180x, and so we divide both sides by 180. And so x is going to be 360 pi over 180. Oops. Let's clean that up a little bit. There we go. And then 360 divided by 180 is just 2, and so that's why we end up with 2 pi. And again, that's in radians. Number 3, name 2 angles, one positive and one negative, that are coterminal. So coterminal angles are angles that have their terminal side in the same place. Okay, so I'm just going to make a little note that coterminal angles have terminal sides in the same location. Okay, now if they're in degrees, then you can find coterminal angles by either adding or subtracting some multiple of 180 degrees. So you can add 180, you could add 360. Oh, what am I saying? 180? No. 360, geez. Adding or subtracting 360 degrees. Or any multiple of that. So you could add or subtract 720, or what would be the next one? 1080, I think. 360 times 3, I'm doing too much arithmetic in my head here. I think it's 1080. So 360, 720, 1080, all those will work. Basically what you want to do is go one full revolution around the unit circle. So if you're in degrees, that'll be 360. If you happen to be in radians, then instead of adding or subtracting 360 degrees, you're going to add or subtract 2 pi. Grab that pi symbol here. Okay, so with the first one, to get one coterminal angle, we're going to start by adding 360. So I'll do 360 plus 135. That's going to be 495. So 490, we'll say 135 plus 360 is going to be 495 degrees. So that would be a positive coterminal angle. We could actually add 360 again to get another one. But if we want a negative one, then we need to subtract 360. In other words, we're going to rotate in the other direction. So 135 minus 360, again, use your calculator here, y'all, negative 225 degrees. All right, so we got one positive, one negative coterminal angles. Each of these are coterminal to 135. So if it's in degrees, it's a little bit easier because you're just working with integers. But when you're working with these fractions in terms of pi, you definitely have to be a little careful. Okay, so we got 3 pi over 4. We want to find an angle that's coterminal to that. And so one way is going to be to add 2 pi. The other way is going to be to subtract 2 pi. All right, so we're going to work these out basically right alongside each other because you're going to work them out very similarly. To add or subtract fractions, you need a common denominator. Okay, so that's in this case just going to be 4. So 2 whole, how do I say this? 2 is equal to 8/4. So this would be 8 pi over 4. And that's going to be the same thing for this one, except we'll just subtract. Okay, so 3 plus 8 is 11, so this would be 11 pi over 4. That would be a positive coterminal angle. And then 3 minus 8 would be negative 5. That's going to give us a negative coterminal angle. So this would be one positive and one negative. For part C, we'll work that out basically exactly the same way as we did part B. Move this over a little bit. Here we have negative pi over 6, and we're going to add and subtract 2 pi to that. So in one case, we're going to add 2 pi, and in the next part, we will subtract 2 pi. Now here our common denominator is just going to be 6, so we want to change 2 into some number of sixths, and 2 is 12/6. So we get negative pi over 6 plus 12 pi over 6, or negative pi over 6 minus 12 pi over 6. All right, so if we add, these are kind of getting close to each other. I think maybe what I'll do is like draw a line here. Just to make it a little clearer what's happening. All right, so negative pi over 6 plus, that's going to be 11 pi over 6. Right, negative 1 plus 12 is 11. And then negative pi over 6 minus 12. So we got negative 1 minus 12. That's going to be negative 13 pi over 6. And here are your two coterminal angles, one positive and one negative. All right, we're done with the first page. Let's move on to the second page here. It says, find the value of each trigonometric ratio. Leave your answer in simplified form. So here, we're just going to have to make sure we know what our ratios are to help us out. I'm going to write, what is that? No. That's not what I want to do. Let's get rid of that. All right, here we go. SOHCAHTOA. It's going to help us out here. And this is just going to help us remind us what the ratios are. So if we're doing sine, so opposite over hypotenuse. So angle measure x is this one right here. The opposite side is unknown. The hypotenuse is known to be 20, but we need to find that opposite side. Okay, so the opposite side squared plus 12 squared equals 20 squared. So 20 squared is 400. 12 squared is 144. We get 144, 400 here and here. Then if I subtract 144 from both sides, 400 minus 144 is going to be 256. So the opposite side squared is going to equal 256. And then I need to take the square root. The square root of 256 is going to be 16. So this will be a Pythagorean triple. Okay, now we know what this opposite side is. I'll go ahead and label it. And so now we can find our trigonometric ratio, which is just going to be a fraction. So sine x equals opposite over hypotenuse. It's going to be 16 over 20. If we divide both of those by 4, we're going to get 4 over 5, which will be the value of sine of x here. And that's your answer. The next part, we're finding tangent of z. Tangent's going to be opposite over adjacent. Z is this angle right here, so the opposite is 16, but we don't have the adjacent. We got to use Pythagorean theorem again. So the adjacent side squared plus 16 squared will equal 34 squared. So definitely going to want to use a calculator on this one unless you just want to do 34 squared on your own. I don't know what that is off the top of my head, but it's 1,156. 16 squared, you might have that memorized. It's a little bit more uncommon, but a lot of people know this one is 256. So 1,156 minus 256 is going to be exactly 900. So this one's going to work out nicely too. The square root of 900 is going to be 30. So that's your adjacent side. All right, so tangent is going to be opposite over adjacent. See, the opposite is 16, the adjacent is 30. So this would be 16 over 30, and that can be reduced. Both of these are divisible by 2, so this is going to be 8 over 15. The last one here is asking for cosine. Here we don't know the hypotenuse. So cosine of x, here's the angle x. And cosine is adjacent over hypotenuse. We need to know the hypotenuse. So we've got, am I going to have enough room here? Probably not. We'll just do the best we can here. We've got 9 squared plus 12 squared equals the hypotenuse squared. So 9 squared is going to be 81 plus 12 squared, which is 144. It's going to be a total of 225. And the square root of 225, you might have this one memorized too. But if not, feel free to put it in the calculator. Square root of 225 is going to be 15, and so that's going to be our hypotenuse. Oops. Go ahead and label the triangle over here, 15. So cosine of x, adjacent over hypotenuse, will be 12 over 15, which if we reduce that, divide both of those by 3, you get 4/5. All three of these ended up being Pythagorean triples. How about that? Where you get nothing but whole numbers. That's pretty cool. Okay, well there's number 4. Take a look at number 5. Number 5 says Duncan is flying a kite. The length of the kite string is 30 feet when the kite is 10 feet above the ground. So let's start to draw a little shape here, a little diagram. Okay, so the kite string, if my person is here, I'll just put Duncan here. I'll label this one D for Duncan. And the kite is over here. We'll call that K for kite. The distance here is, the length of the string is 30 feet. So we'll label this 30. And it's 10 feet above the ground, so it's going to be just the height here. So that's going to be 10 feet here. It says if Eloise is standing directly below the kite, so Eloise is right here at this vertex, find the distance between Duncan and Eloise, which would be this distance right here. So this really is just going to turn into a Pythagorean theorem problem. Okay, so we'll just call this the distance. Okay, I'll call it DIS for distance. All right, so let's go ahead and set up our Pythagorean theorem here. We've got the distance squared plus 10 squared equals 30 squared. 30 squared is 900. 10 squared is 100. So we have 100 and 900. Now those work out really nicely. 900 minus 100 is going to be 800. So we have the distance squared equals 800. So now we just need to take the square root of both of these to get our answer. So square root of distance squared is just distance. So the distance is going to equal the square root of 800. So this is something you'd want to put in the calculators. This has round to 3 decimal places. So the square root of 800, I'm going to go ahead and type that in. And I'm getting 28.284. 28.284, and that is in feet. That seems to be reasonable given our diagram here. Okay, that's number 5. Let's take a look at number 6. These are our special right triangles, and so we'll use those special right triangles to solve both of these problems. For the first one, we've got a 30, 60, 90 right triangle, and the ratio here is going to be x to 2x to x root 3. So if 9 is the x root 3, I'm going to set up a little equation here. Say that 9 is x root 3. X times root 3. So x root 3 and then I'm going to divide both sides by root 3. So I'll have x equals 9 divided by root 3. And this is essentially your answer here, but we do want to rationalize it, and so that means we need to multiply both the numerator and the denominator by root 3. And so my answer is going to be 9 times root 3 over 3. Yeah, you might notice, hey, we can actually simplify that a little bit. Let me move this over a little bit. Just give me a little bit more room here. We can simplify that a little bit because 9 divided by 3 is 3. So this is really just going to equal 3 times root 3. Oh, that doesn't fit very well over there either. I guess I might as well just put it right here. Okay, but this is really how we got all that, how we got started here, was if the ratio is x, 2x to x root 3, and that means this is the x root 3, and then we can solve that for x. All right, so for y is going to be 2x, and so we'll have y equals, and let me click here, oh, there we go. Y equals 2x, right? It's twice the short side, and we already figured out what x is, right? That's going to be 3 root 3, so that's going to be 2 times 3 root 3. 2 times 3 is 6, so this is going to be 6 root 3. Now it should be double whatever the short side is. All right, there's the first one. The second one is a 45, 45, 90 triangle. Okay, the ratio here is x to x root 2. So if this is x root 2, this one's actually a little bit easier. If this is x root 2, then x has to be 2. There's really not a whole lot of work to show there. If you really want to solve this algebraically, you would say that 2 root 2 is x times root 2. Kind of similar to how we set up the previous problem. And then if you divide both sides by root 2, you just get 2 equals x. All right, our last problem here, evaluating the following, no calculator. Okay, so here we're going to use those special right triangles. All right, so I guess I'll go ahead and just sketch them out here. So for the 30, 60, 90, something like this, right? The ratio is going to be x to 2x to x root 3. Okay, and that's when the smaller angle here is 30 and the bigger angle here is 60. Let's see if we can squeeze those in here. 30 and 60. The bigger one is 60. Let's make that a little smaller so you can read it a little nicer. So yeah, that would be 60 degrees. And then this other smaller angle is the 30. All right, so we'll knock out both sine and tangent here. Okay, since these are both having to do with the 30, 60 triangles. So for the 60, sine is opposite over hypotenuse. So here's the angle we're looking at, 60 degrees. The opposite side is going to be x root 3. The hypotenuse is 2x. And then we can reduce that. X over x reduces to 1. So our answer is just going to be root 3 over 2. For the tangent of 30, that's going to be opposite over adjacent. Okay, so with respect to this 30-degree angle measure, the opposite side is x, and the adjacent side is x root 3. Once you simplify this by reducing the x over x to 1, you get 1 over root 3. And if you rationalize that, you will get root 3 over 3. If I multiply this by root 3 over root 3 times 1 is root 3, and root 3 times root 3 is 3. So our answer over here is root 3 over 3. Now for the 45, 45, 90 triangle, let's go ahead and sketch that out, see what that would look like. That's going to be an isosceles triangle, since two of the angle measures are the same. This is just kind of a rough sketch here, but it gets the job done. Let me go ahead and label these as 45 degrees. So this angle and this one up here, so it doesn't really matter which angle you look at since they're both the same. But the ratio for these side lengths are going to be x to x root 2. There we go. All right. Sorry, it takes a little bit of time to type all that out. Okay, so now if we're looking for cosine of 45, what we're looking for is the adjacent over the hypotenuse side. Okay, the adjacent over the hypotenuse. So the adjacent side here, it doesn't really matter which one you pick because you can see how both of these legs are x anyway. Adjacent side is x, and the hypotenuse is x root 2. So when I reduce that, what I get is 1 over root 2. And after I rationalize that by multiplying by root 2 over root 2, I get root 2 over 2. And that'll be your answer for cosine 45, root 2 over 2. So that about wraps it up for tonight's review over Unit 6. I hope you understand these concepts a little bit better than when you first started watching the video. Hopefully this helped. As always, please reach out if you have any further questions. But other than that, thanks for watching, and y'all have a great night.